Hello everybody, welcome back to the IBT YouTube channel. Today I will be talking about the Biology IA. If you haven't already, please subscribe to our YouTube channel and also please follow our Instagram pages where we give updates and you can ask us questions and recommend videos for us and we will respond. So if you haven't already, please go follow our Instagram page and subscribe to our channel. So today I will be talking about the Biology IA. The Biology IA is an important aspect of the biology subject as a whole. So let's go see what the Biology IA really is. Like every other subject in the IB, biology also has an IA component, which basically is just required for students to design and conduct an experiment or investigation on a specific biological topic of their choice. The investigation should be based on a research question that the student later formulates by themselves. And the experiment or investigation they design has to involve collecting, analyzing data to draw valid conclusions. That is a very, very important task, as this basically just allows the examiner or your teacher who was marking it to see how well the student can apply biological concepts with data analytical tools to, show an experiment, like conduct an experiment and display the results. So I'll be going step by step through my IA. And yeah, we'll be seeing what specific aspects and components you need to have in like background in the experiment, what tests you need to conduct, t-test, p-test, all those things. And then yeah, hopefully wrap up. So yes, the Biology IA is a long, not tedious, a long task, and it can get a bit monotonous. So start early so you space it out and not just cram it all in one go. So as you can see, this is my Biology IA. I was JMT 584. So you basically got to start your entire Biology IA with a personal engagement section. So my essay was basically about enzymes and how increasing the temperature of a 2% starch concentration solution of amylase affected the test like for iodine. So it was if I increase the temperature of my starch concentration, would it affect amylase's activity? So would it affect enzyme speed, enzyme reaction? And that was measured through an iodine test for every minute until color change stopped occurring. So in my personal engagement section over here, I basically just talk about how I was brought up in a vegetarian household and how I always ate curd yogurt. So when I always ate yogurt, it's a very high protein and a high protein dish with numerous probiotic benefits. But my mom did use a chili and put it on top of the curd in order to increase the speed of its setting. So that always interested me as to how that can like occur like as a catalyst. So I use that as my personal engagement factor to show how it motivated me to take this how that motivated me to take an interest in enzymes. And yeah, that's how I started my IA, because yes, I found enzymes very interesting. So yes, I basically use that just with different enzymes, because my mom used a red chili which contains glutaminase. So I did not use that enzyme, but I did use amylase. So that was my personal engagement. Ensure your personal engagement is like kind of genuine, because if it's not very genuine, it's kind of hard. It's kind of easy to pick up. So usually try to do it from like a cultural background or like a personal experience or something out of the ordinary, because your personal engagement does count. It needs to seem kind of genuine. Next, my research question, kind of straightforward, just boom, 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 what my experiment exactly was about. So yeah, that's basically it. Background information, actually, believe it or not, is more important than you think. You do need to explain almost everything. This is a pretty big section of your mark, because they need to know that you have done your research well before you've like undertaken this experiment. So basically you got to just explain what an enzyme is, basics, and then what an enzyme is, why you're using temperature, what your enzyme is what I've done here. Amylase is an enzyme that is scientifically classified as glycoside, starch, etc., etc. Definitely have some sort of diagram here, and then explain it, because if you don't have a diagram, it's not that interesting. Have a diagram, because if you have a diagram, it shows your examiner going up and beyond of what you just usually have to do. So have a diagram, and then as you can see, I've just talked about my diagram here, like what it's representing. So yeah, so just remember that the background information is just about the enzyme, like what I've done here is what is, like for mine, I'm talking specifically, but what are your two variables, your independent and dependent variable, kind of explain them, give background information on them. Definitely use a textbook for this, because they will be seeing that whatever your knowledge is not just straight from the internet, but also from the textbook. So that's what I did here. Then I also did the same for starch. So I did talk about I talked about amylase and the two variations of amylase, and I also talked about starch and how starch, like how the enzyme breaks down starch to that. So as you can see, I've just explained the diagram over here again. And then lastly, I've explained how temperature in general affects enzymic activity. So this was a more general thing of how rate of enzyme activity is affected by temperature. Another diagram explained it. And then finally, I just did a bit of a conclusion, which is what, like, after all the background information, I've just talked about my how all this background information helped me design my experiment, and what my experiment is, and little details. I explained why I chose the 5 degree Celsius intervals, because like I wanted to see how minimally I had to increase the temperature in order to see a change. And yeah, and I even explained that I had the optimum temperature, and then I had like 10 degrees below, 10 degrees above, so 40, 10, 10. So I've explained most of the things here. So that's what background information is all about. Then you have your hypothesis here. Hypothesis is pretty similar to the research question over here, just like what you predict is going to happen. So if the temperature of the water bath is here, this is because the temperature increase of space, speed, and motion of enzyme and substrate will consequently increase, resulting in more frequent collisions occurring between amylase and starch. So this was basically, I just did this from common sense. So you do know that as the temperature increases, it's supposed to increase. Your hypothesis usually is always going to align with your results, because you're pretty much just guessing what's going to happen. You have to just display it through your experiment. So I just knew that if the temperature increases, it's going to be more collisions occurring between amylase and starch, hence the temperature will increase the speed and motion of enzymes, increasing the breakdown speed of the substrate, which is enzyme and substrate. Yeah, so that's what that is. Then you got to show your materials, like a regular experiment, what materials you're going to be using. And then a variables table, you got to show your controlled variables, what variables you're controlling, which you like having, like the volume of starch, I can control the source of starch concentration, I control all of these things. And then you're going to mention an uncontrolled variable, which would be like something which it's not on my hands anymore. So mine was an external heat factor. So the sunlight could potentially affect my results obtained, even though I was in a closed dark room, there were windows, so that could increase the speed more than it should have been increased. Like 30 degrees could go up to 32 degrees because of the sunlight. And then you talk about your independent and dependent variables. Just that was a pretty easy table to do. What's your independent? What's your dependent? How are you controlling? How are you controlling? Then the method used in this, all right, so this is important. So the method used for the experiment conducted in this IA was inspired by bum bum bum. And you gotta, okay, so in your biology IA, it is important that you show like a form of inspiration, because your IA markers know that it's not you who just came up with this experiment. So it's really important that you cite, like if you, like people would have obviously conducted this experiment before you have. So it's important that you actually talk about inspiration aspects here. Like I did, I looked at BBC's and SEB biologies. So I mentioned both of them and saw how their methodology and experiments worked, the results they got. However, I did modify it to make it more unique, and like I had to make it more like mine, right? Because this is, you have to have your own elements to your experiment. So I did have an overall look of everything, and I did get inspired by them, but I also had my own experiment. So it is important that in your method you do ensure that you you mention who inspired this, or if you saw any other experiments and studies which helped you during the setup of your experiment, etc., etc. So here I just talk about the all the equipment I used, and then here I just talk about the steps I did. I did take a picture of my experiment setup, and yeah, and you got to do a risk assessment. Please ensure you do that. I forgot to do that until like the end, which was really, really bad. So please ensure you do that. The risk assessment is quite easy. It's just the ethical concerns that were present, environmental concerns that were present, like sure you didn't, just straightforward. And then the table, you gotta ensure you just ensure that you emphasize that the equipment you used, the safety hazards that were present, and how you reduce the risk of this. It's pretty straightforward. And then results. So this is the most important part. So all this is good, but this is where it gets more interesting. So you got to just give your results in a qualitative way. See, I did qualitative because mine was not really quantitative data. It was more qualitative, as I was measuring if the starch concentration, like if the enzyme broke it down by iodine, the iodine test, using iodine as a measure to see if the color changed. So I also had quantitative data. So I did my IA was predominantly based on qualitative data, but I also did have quantitative data to show how many seconds it took for color to change. 900, bit crazy. So, and as you can see, I've just shown my two images of the iodine color change occurring, and that's when starch was completely broken down. Starch was completely broken down here. Showed that in the quantitative data, and then I did some sample calculations. Wow. Standard deviation, mean. Love that. So all sample calculations were performed for the results derived from the first temperature investigated. So you don't have to do it for everything, but you do have to do it just for one specific. So whichever one you think would show your best, like show the best results. So I chose 30 degrees here, and I calculated the mean. I calculated the standard deviation. You do not have to hand calculate this. The mean is kind of easy, so I just did it like that. But standard deviation, I did use Excel, because why make your life hard when you have easier tools, right? And you don't get marked down for that. In fact, they'll be really, really happy that you know how to use Excel. So use standard deviation, Excel, very, very helpful. And I just put the results I got here into this. You gotta show how you got it though, so which I've done here. I just added it here, this and this here. So you gotta like ensure you show them how you got your results. So I did that here, and I put it on a table. They don't say this often enough, but it's very, very important that the biology IA is all about tables. They love tables, obsessed. Any information, data, stats you get, put it in a table. If you put it in a table, your marker is just going to be jumping. It's going to be so happy. So I just always have table 6, graph 1. Make sure you like write what the table or graph is showing, because it's actually not straightforward. So, and then I just put the mean times for amylase to break down starch in the 5 different temperatures in a graph, because graphs are pretty and makes you look smart. So, note here, all error bars have been calculated using the standard deviation rules. Yes, you do need to have error bars if you do have a line graph like mine. It is very important to have error bars, because it shows that you're going above the IB biology syllabus and taking it a step forward. So if you really want and are looking for those top like 7 marks, like level 7 marks, then you do need to have error bars, got to conduct a t-test and all those things. So I just talk about my results now. This is just a discussion like you would have done in your other IAs, math IAs, physics IAs, whatever IAs you did. You got to like discuss your results. And then I also conducted a null hypothesis and an alternative hypothesis here, and a t-test to t-test, and then there's alternative. So t-test overall, these two are components of the t-test. So as usual, again, I used Excel, very good. Use Excel, makes your life easier, also shows the marker that you're really smart. So as you can see here, the temperatures and the results I got from the t-test explained the values of the t-test and what they meant. This is a more mathematical thing. So if you're doing SLAI or HLAI, good. This is really good because you do learn about these things in math. So it's very, you can apply that over here. Not really sure about the AA syllabus, but I'm pretty sure you guys learn about that as well. But AI, so yeah, you'll really be able to apply the math here. It was good. Standard discussion here, just discussing my results from the t-test as well as the results I got, what that meant for me, what that meant for the experiment, what that meant about my hypothesis. So that was just a discussion here. So the discussion is relatively long, as you can see. It does need to be a very long aspect because you're discussing your entire experiment and including the results, t-test, everything. An extension. Okay, so this is not a necessary aspect to have. However, I do recommend it. When you do an extension, it does show that you are actually thinking above and beyond of what just needs to be done. So like I said here, this experiment could possibly be extended if the amylase investigated was obtained from a different source, like possibly Bacillus amylase. It's a different type of amylase. Other factors like pH, substrate concentration, enzyme concentration, or the presence of an inhibitor could be investigated to extend this experiment and further investigate the effects of changing these factors on the enzyme investigated. So an extension aspect is essentially saying, great, my experiment was good, really good. I'm really happy with it. However, it could have been better and error could have been reduced if I did this or if I did this. So it's just like a mini evaluation saying, for my next experiment, I will aim to do this. Evaluation, like we all know, it's this was good, this was bad. How can we make this better for the future? So, and error. So you know how we did the error bars over there? You also need to address systematic error, random error that could have occurred, and then improvements to avoid these errors in the future. And then finally, the conclusion. Yes, the conclusion. And ensure all these sources are what I used, but ensure you at least have 10, because as the biology IA is you designing an experiment by yourself. However, it is important to at least have at least 10 sources because it shows you've like researched well and all your data in this IA is reliable. Let's check how much I had. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So at least have 10. 10 is, I think, a good number to have for your references. So yes, that is it. Yep, so basically that in essence is the biology IA, all the components I did, what I thought was necessary and what I think is necessary for you to do in order for you to get the top marks. Honestly, if you start earlier and get it done earlier, it's really not as hard as you guys think it is. It's actually very easy. A pretty straightforward IA, one of the easiest, I would say, easier than the business IA or the economics IA. The biology IA is conduct an experiment, show your results, conduct these tests, all good. So I really hope this video was helpful to you guys, gave you guys some tips. If it was really helpful, please leave a comment down. We'd really appreciate that. And for the next couple of days, weeks, months, not months, just days, weeks, we will be waiting for you guys to give us tips, what you would like to see on our YouTube channel, any recommendations or anything. So please just drop that down below in the comment box. Don't forget to follow our Instagram page and please subscribe. And we'll see you guys very soon with another video. Bye.